So hi, this is the second lecture for week 8 and we are learning some system building skills right now, and the next system building skill that we are going to have a look at is networking. But before I actually introduce you to some of the networking code, let me just give you a brief overview of what networking is as a field, because you may not have a background in it. So let us just start with something that is very basic. What really happens when you try to open a web page, right? Everyone uses a browser, I'm pretty sure. But whenever you try to open a particular web page, what exactly really happens, right? So you type the address of whatever page you want to visit at the this particular address bar of the browser, and then you press enter. And well, for you it basically loads like this, and you really don't care what exactly happened in the background. But now, since we are computer science students, you should probably know what really actually happened in the background, right? So in the whole field of networks, these strings, right, strings like IITL.ac.in, it doesn't really matter. In fact, anything like google.com, it doesn't really matter. What really matters are numbers and not strings, right? Actually, they are bits, to be honest, but we can take everything back to bits. So let's not go to that level. So two of the most common set of numbers that networks use are IP addresses and port numbers. And IP addresses, I think you already know about these things, but still I'm going to give you a formal introduction to them. So basically, IP addresses are unique identifiers for the members within a network. Okay, so these members are part of a network. This network could be a local network. A local network, for example, let us say if IIITL decides to create a lab, and you guys are sitting in that same lab, so they are basically nodes or systems added on the same network. So such a network is called as an intranet, and you all know what is the internet, right? It is basically a worldwide network. But irrespective of whether it is an intranet or an internet, IP addresses are there. Okay, they are basically unique identifiers for the members within a network. And port numbers, you can say that port numbers along with an IP address can be considered to be a particular communication channel between any two members of that network. Okay, so not just the IP address, you also need a port number, and this port number identifies the it's kind of a communication channel. Okay, so one machine can have multiple communication channels, and you identify a particular communication channel with the help of a port number. So here, whenever we typed this IIITL.ac.in, there is neither an IP address nor a port number here, right? And if you want to know what these IP addresses are, you can actually do something like this. You can use the ping command, and just type ping www.IIITL.ac.in, and you will get something like this on your screen. And this part within the ping is actually the IP address for www.IITL.ac.in. And an IP address, you have probably already seen, is a combination of four integers separated by dots. These integers are not really it's not really a good way to tell you that these are simple integers. There are certain restrictions on this, on what integer could be where, and there are different types of IP addresses. But for our purpose, let us just assume that these are four small integers. So this ping command is not really meant to check out the IP address of a particular website. There are other commands which are specifically meant to give you more information about this whole this whole process where you are going to connect to a particular domain. So one of the commands that you might find useful is known as the dig command. So what you really do is you can try to use dig command with a domain such as google.com or IIITL.ac.in, and it will show you far more information than the ping command. So this is an example of what will happen if you try to dig the domain www.IIITL.ac.in. And if you want to know what exactly is the IP address associated with this string, Okay, this is the string, and what exactly is the IP address. Then here you can actually find the IP address, and the CNAME entry is basically the entry that tells you what exactly what exactly can be typed in place of this, right? So CNAME is more like an alias. So here it says that IITL.ac.in is basically an alias for www.IITL.ac.in, and in either case the IP address that you will get out is this. But this is the IP address of the machine that we are trying to communicate with, right? So you understand that this IITL.ac.in is just another machine on the network, on which you are trying to communicate. Your machine is also a part of the same network, right? And if you want to know your IP address, then the command to do the Linux command to find that out is IP, and then followed by the by the switch A. Okay, so something like this. If you type IP space A, some information here will be dumped. Your IP address is basically hidden somewhere here, right? So you can see that this is not the kind of IP address that the other party had. It will probably start with 192 or 10, but that is understandable. Don't be worried about that. And what about the port numbers? I said that a particular communication channel between two machines must have a port number. Well, the port number we did not really supply when we typed IITL.ac.in. Why? Because that is implicitly implied here at it. That is 443. So whenever you are going to use HTTPS, it is going to be 443. Otherwise, it will be 80. If it is HTTP, the port number that is used is 80. And this 443 is also known as a well-known port. It is a well-known port, as in this number is predefined, okay, preoccupied by a particular standard, and we call these communication standards as protocols also. Okay, so the HTTPS or hypertext transfer protocol secure is a protocol through which two machines communicate with each other over let us say the internet. Let us just say the internet. There is something known as the OSI reference model. So we'll revisit the term protocol once we have seen that. So a website that communicates over HTTP, of course, uses port number 80, and all those websites which communicate over HTTPS, these are two different protocols. It's not too different, but yeah, for now you can just assume that they are two different versions of the same protocol. They use 443 instead of 80. By the way, on your machine, there could be more than one port which is being used for communication with, let us say, IITL.ac.in's web page. You generally don't need to know this because they are allotted automatically. And but still, if you want to check this out, there is a command called netstat. You can type netstat minus ntp, and let us say I just want to know what are the sockets, sorry, what are the port numbers that are being used to communicate with that particular web page. Then this command will give you the information, and you can of course use a grep command after that to figure out because there might be other port numbers here. So if you just want to figure out the ports that are associated with the IIITL connection, you can type something like this. So what exactly is this so-called OSI reference model that I'm talking about? So, a lot goes on in the background when two machines communicate over a network. Okay, we just talked about some addresses and ports, and all these things work in the background. But there's far more than this. The overall process of communication, it actually involves multiple layers of processing, right? And the layer where you actually supplied the name of that website, IITL.ac.in, that layer is basically on top of this whole set. We also call this set as a stack. So the communication medium, the wires and the Wi-Fi, the routers and all those things, they are much below in this processing world. In fact, the communication medium is at the bottom. of the communication, whereas the name of the website that you provided, that is basically much higher, probably at the highest level. So the OSI reference model is a kind of a conceptual model. So it becomes very difficult to understand all this processing without dividing them into different groups, without dividing them into different layers, for example, right? So this OSI reference model, it is a conceptual model which divides the whole process into 7 layers, and each layer receives some data. It processes it in certain fashion and then just passes it on to the next layer. It's like a, a musical chair kind of a thing. So you keep it for some time, you do something over it, and then you pass it on. And different layers, they basically add or remove some information from this data. Okay, this information that every layer adds on top of the actual data, that is used for communication, right? So usually what happens is that there is a kind of symmetric processing. So whatever data is added by, let us say, layer I on the sender side, it gets used up by layer I on the receiver's side. So this is just a way to show you how OSI reference model looks like. So this is, let us say, this is the sender of the message and this is the receiver of the message over the network. Then at the sender, this is where probably you typed www.replytl.ac.in, and then from here onwards some processing starts. Okay, things happen in the background. It's like a cascading effect. So the data starts flowing from here and it goes down up to the physical layer, and physical layer is basically the layer that communicates with physical channels. Okay, physical channels as in it is that layer which talks to the router and the if you have a broadband connection, for example, that wire that is coming to your home, managing that wire, let us say, is basically the job of the physical layer. Whereas uh, you know sending a WhatsApp message is happening here. Probably WhatsApp is not the best example, they have a different kind of stack. But yeah, let's say you're chatting on your browser. Okay, so it's probably something like this, that you type something here and then it goes up to your wire, the wire that is there in your home, and then it is transmitted somehow again it reaches the sender using the communication channel. Of course, it may not be one communication channel, there will be many communication channels that might come in between. But at the receiver end, exact opposite of what happened at the sender end happens. So the physical layer basically accepts the data. So maybe your friend, right, to whom you sent the message, at his or her house, the wire brings the data uh, to to his or her house, and from there onwards there is a reverse processing. So whatever data was added by these layers here, it gets removed, and then finally at the application layer, it is just the data that you sent from your side, right? It's a very abstract way to understand it, but one way to look at it is something like this. At the sender, you just have data, that is what you provide to your, let us say, to your system, and then it just, the data keeps on flowing from different layers. At each layer, the size of the data increases, so something more gets added to it, and this something more is basically the magic because of which the data gets transmitted safe and sound and then shown back to you. So at each layer something more gets added to this data. The original data remains, but more stuff gets added. And then finally, when the data reaches the layer 1, the bottommost layer, at that point of time it is just zeros and ones which are then transmitted over the communication channel. At the receiver end, this is what the receiver receives, and then here the data actually flows up. Okay, so each layer picks out takes out the data that was meant for it and then passes it on to the layer just above it. So one layer after the other, everything gets trimmed off, and then the application where it was meant to go, it only receives this data, okay, the data that was supposed to be sent to it. So everything works in the background, nothing really is shown to you. You don't really need to know much about these layers as well. In fact, some of these layers are not even that important. You only probably need to know about two of these layers, okay. The rest of the layers you probably don't even need to know. For our purpose, these two layers are the only important layers. The first layer is basically the layer number 4, okay. It's also known as the transport layer. So the transport layer is responsible for creating an end-to-end connection between your machine and, let us say, the machine of your friend. Yeah, so this is the layer that manages a connection, okay. So at this level you can say that transport layer is responsible for creating and managing end-to-end connections. So to do so, it uses that IP address and the port number, right? And that is why port number is so important, because two machines can have more than one connection, more than one active connection between them. So the IP addresses are going to be the same, but it is the port numbers that will change on either ends. And this is how you will be able, the machines are able to differentiate between multiple connections. And this layer is also responsible for sequencing. So basically, if your message is very large, it will be broken up into different packets and then sent across the network. So this layer also makes sure that everything is received in the order it was supposed to be received, okay. So ordering also, because we are living in a world where physical mediums are prone to errors. So sometimes you may have to resend a particular packet. Sometimes certain packets might be received multiple times out of order. All those things are managed by the transport layer. And uh, yeah, in most cases the data will actually travel through multiple hops before it reaches your destination. The other layer that you need to know about is the network layer. The network layer is basically the layer which deals between devices that are on the same network, okay. So basically what you try to do is, I mean, not on the same network per se. I mean, there are so many problems with the terminology here, but when I say same network, as in I'm assuming that you are connected at least via some mechanism to your friend's machine. It's technically speaking, the same network is not the right word, but the idea is that this network layer knows a little bit more about the intermediate connections that are going to happen from your machine to your friend's machine, right? So what are the different number of hops, the different number of devices through which your data is going to travel? That is managed by the network layer. The network layer has information of the intermediaries in your communication. For now, just assume that that is what is the job of the network layer. And with an IP address and relevant port numbers, you know, any two members of a network can communicate with each other. This is all that you need to know. I know it was a very fast overview of networks, but this is the gist, that as long as you have the IP address and port number, you can basically start communication between any two machines on a network, okay. So in the next lecture we'll see how to do this communication with the help of IP address and port numbers using POSIX POSIX sockets. We'll have a look at it in the next lecture, okay. Thank you, bye.